And we're recording. Just wanted to show you a couple things on Moodle. So this is me logged into Moodle. It should look similar for you. One of the things to note, since some of you may not be aware, is that you all get free Microsoft Office by virtue of being a student here. So if you want to install on a computer, you can click on this link right here when you log into Moodle, and it'll give you the instructions on how to gain access to it. So just so you know that and know how to get it. Astronomy 111 is our class. And if there's any love in the world, yes, it's loading. And so we have the astronomy Moodle page, which has lots of cool stuff. One of the things I want to point out for tonight is these useful sites. I have the top one there, the constellation pronunciation guide, because some of them we pronounce incorrectly and don't know it. Others we pronounce incorrectly and intentionally. One of the ones that I always think is funny to pronounce is booties, which I always pronounce booties. And I'm pretty sure it's supposed to be something like booties. I've seen it, different ways of how it's supposed to be pronounced. But it's kind of interesting just to look at that. StarCalc planetary software that's free that you can install on a computer to do planetarium software. But of much more interest in that regard is if you have an Android phone, there is the Google Sky Map, Google supports, that you can use on your phone. You can go like this and it'll show you what's in the sky and tell you what the constellations are, what the stars are. You can click and get information about the stars. There's a number of them. These links are actually old now that I think about it. The prices may not be the same, and they may have gone to newer and better versions of the apps. There was StarWalk and StarWalk HD. That was about 2 years ago when I did those. Yeah.
The basic version of StarWalk, I think, is free.
Is it now?
Yeah. There's a lot of in-app purchases, but
yeah.
Part's free.
But those I definitely recommend getting an app like that for your phone. There's another one that I used to recommend because one of the students my mom had at Mountain View Elementary School, whatever, her first year out of college, wrote one of the major software for iOS for observing the sky. But it's more expensive than StarWalk, and it's a little more convoluted to use, so I took it off the list. But I recommend you getting one of those packages just so your phone can be the great guide anywhere you are in the world. Coming back up here, astronomy picture of the day. Let's just go there. It's kind of cool to look at the picture of the day. You have pictures that are posted here every day of something really cool. So just looking at this, what would you call that feature? It's a nebula. Nebula is singular, nebulae is plural. Okay, so it's a nebula. It's a cloud of gas. Very interesting to look at. It has a description here. So this is the Soul Nebula. Somebody's soul is on fire. And it gives you some history here, what it's supposed to be about. You can go to another one and should go to another one here. Okay, yeah. This here, what do you suppose that is? Well, it is a star. It's not a solar flare, but that star is Sol, otherwise known as the sun. Is that what? Well, the sun is a plasma, so sure. What we're looking at, you look at this surface here, stuff is really cool looking. It kind of looks like, okay, I didn't mean to do that, but it kind of looks like a prairie fire or something. And that is actual little jets of gas coming off the sun. And then you see here looking on the limb, we call this surface, if you will, the limb. You see gas shooting up off of the star of the sun. And there's always interesting stuff like that going on in the sun. So it's a very cool picture, pretty decent high resolution picture. So that's always fun, the astronomy picture of the day if you're bored. Let me click on the Northern Lights. I think this is just a website that is focused on Northern Lights. You might say, but this is astronomy class, right? Well, how do Northern Lights have to do with astronomy? Well, Northern Lights are caused by the sun blowing lots of charged particles at the Earth. And so this is a website that is devoted to, and somewhere it's got pictures. Okay, not on the front page anymore, but it's something that's devoted to, and there's one picture, Northern Lights, fun stuff. They have to do with astronomy. The next one's here. Hyde Observatory is an observatory over at next to the golf course by Holmes Lake. And Euler Planetarium is the planetarium at University of Nebraska Lincoln. Remember I told you I wanted you to know about the benefits of science to society? Well, this here is a website, I think it's a NASA website, to list the benefits of space exploration. And so it has a bunch of materials here to help you look up all the different things that they consider as good things for benefits. I, of course, am not going through everything here. One with some good quotes, some products of space technology. So those three are all for how does astronomy research actually help us. Then we get to space weather and heavens above. Those two are super bueno sites. Space weather is a website that's devoted to telling you what's going on with the sun and how that's affecting us. And so it will have, I believe it's a close to live picture of the sun here. That picture there. There's a picture. It says Steve is not. See, that's all news to me. I'll bet you it has something about the asteroid. Do you guys read about the asteroid this weekend? In Alabama, there was an asteroid that came in overhead, and for a brief period of time, it gave off light brighter than 40 times the light that comes from the moon. So it's really bright. What's causing this? The asteroid is going through the atmosphere. It is heating up the atmosphere, ionizing the atmosphere. The ionized atmosphere is then giving off the light. But yes, it is, because it's so hot, it essentially burns or melts, breaks into pieces. There might be little fragments that hit the Earth, but they don't think there's anything big. This was believed to be about a 6 foot in diameter asteroid, so about the same size as my height. So relatively small, but gave off a lot of light, so pretty cool. I love this here, the near Earth asteroid list. We always wonder if we're going to get hit by an asteroid. Well, the Earth's atmosphere gets hit by large asteroids like every month, but not super big, not catastrophic. This is listing ones that have been tracked and how close they're going to come to the Earth and how big they are. So if you look at the ones that are in red, those are the ones that are considered dangerously close. And the distances are lunar distances, the distance from the Earth to the moon. So you see this one coming up on August 20. Okay, so that's past actually, right? We're on August. Wait, today is August 21, right? Yeah. So yeah, this one from yesterday that was 2.8 lunar distances away had a diameter of 10 meters. And of course, if it's more than one lunar distance, we're really safe. If it's a lunar distance, depending on where the moon is, it could hit the moon. And if it gets closer, we're in trouble. You see there's a really big one there, 490, but 12.3 lunar distance is probably not a problem. The reason they consider the ones dangerous if it's more than a lunar distance still is because these are calculated distances. What if there's some variation they didn't account for? We're very sure it's not going to hit us, but there is at least a probability. So it's kind of cool to look at these, and there's bigger lists. These are just the major ones. Something that's scary is the big ones that hit the Earth's atmosphere, almost always they don't find them until after, or the near misses, they don't find them until after often. So it's hard to find these things because they're small. They don't really give off light. They reflect a little bit of sunlight, but they're small, so not a lot. I am going to click on the picture of the sun, come back up here, because that should take us to a nice big picture of the sun. And when you look at the sun, you see these little black spots, like right there, right there. Those are called sunspots. They're storms on the sun. When there are lots of those, the sun gives off more radiation, causes more heating to the earth. When there are very few, gives off less radiation, less heating of the earth. The sun is the major player in the earth's temperature. And the sun is theorized, no guarantee it's true, that the sun is going into a dormant period like it did in the Maunder minimum. And if the sun goes into a dormant period where it doesn't have many storms, it'll cool off just a little bit. That is, the amount of radiation received will be less, and it would cause a global cooling trend. And so, like within the next 30 years, if it's really going into a dormant phase, if the Earth doesn't cool, then we will know for certain that man is responsible for any global warming. So I think that's good, just because right now it's such a politicized thing and we don't know that much about weather. Heavens above, if you ever go out and you're like, I want to see a satellite, I wonder if there's any satellites that will be out tonight. Heavens Above is a website that will tell you any satellites that will pass over, when you can see them, where to look, how bright they will be. So it's really cool. Just a real odd coincidence. A couple years ago, the beginning of school year, when Nathan was, I think, a junior, we were having a high school get-together thing. And I was like, I wonder if there's going to be iridium things. And I look it up on my phone, and it says there should be one right now. And I look where it says, and there was. It was like the perfect timing. Yeah, that's this link to lecture recordings is not live yet because I haven't uploaded any of your lectures yet. I will do it so you can come here and watch the lectures. I just haven't done that yet. Likewise, the completed lecture slides, I haven't posted those, but I will. I will get all the lecture slides so you can view them. So you don't have to, like some people, take pictures or try to scribble everything down. You can't get everything written down. So it's good to have those. The real reason I came here was homework 1. So homework 1 is due tomorrow, not at class time. It's due at 5 if you turn it on paper, or by 11:59 actually if you turn it on the computer. So if we click here on homework 1, it turns out there are no chapter 1 questions in our textbook, so I had to take questions that weren't questions from our textbook. Just 4 questions, and notice the instructions. For every question, you need to have reasoning given for your answer. Some questions will be, what is, and it asks for a number. Well, don't just write down the number. Show how you calculated it. Or, some of them, does this happen? Don't just say yes or no. Give a reason or explanation. If you just have the correct answer with no reasoning or explanation, you'll get 1 out of 10 for the problem. I want to make it clear, so nobody's like, I didn't know that I was going to not get full credit if I just put the answer. So I want it clear. You need to have that. That's why it's in red there. So you just have, what's the difference between our solar system, our galaxy, and the universe? There's a lot of differences. There are some similarities. So, find some differences and write them out there. What are the largest known structures in the universe? Talked about that last class period. How does scientific method give scientists a way to know about nature? Obviously, that's important to me. And list the 4 steps of the scientific method that you will be required to memorize for the 1st and 4th exams. And you can see 2 people have already submitted their assignments. Good job, you hardcore students. Now, on to my PowerPoint presentation, which I suppose that will be a way to start it. So tonight we're going to talk about observing the sky, and at least according to the app on my phone, the sky is supposed to be clear tonight. I'm still not convinced, but it's what the phone said. So, oh man, I've got all kinds of faith now. I mean, if we can calculate global warming, clearly we can calculate if the weather's going to be clear within an hour. It said it'd be clear until 2 a.m. Okay, so observing the sky. This is a really cool picture taken from Chile. What do you see in this picture? Okay, is that the Andromeda Galaxy? I can't tell you, but I can make a pretty strong guess. I think that these have got to be the two Magellanic Clouds, just because of their proximity to each other. He knows about the Andromeda Galaxy. He knows a little. He's ahead of the game. But those are galaxies, very clearly galaxies. They're not part of our galaxy. They're a big bunch of stars. The two things over on the left.
I just noticed that. Okay, sorry.
So I think those are the large and small Magellanic Clouds. Why are they called the large and small Magellanic Clouds? Well, because when Magellan was sailing South America, or in the southern hemisphere, his sailors saw those things up in the sky. And so they're named after Magellan, the two objects they saw up there in the sky. What is this thing here? Whoops, didn't mean to do that. I've got to actually turn the pin on. Turn the pin on. I chose a, yeah, I think that must be on. Nope. That is the Milky Way galaxy. Thank you for taking me out of my misery here. Pin. I hit the button for pin. Hopefully you saw that I hit the button for pin. Anyway, yes, that's the Milky Way galaxy. The first time I went out at night and looked up and saw the Milky Way galaxy, I thought, must be a cloud up there. That is the light from millions of stars that are so close in angle that it just looks like they're all just a cloud of something. But it's individual stars making all that light. And then the dark part is gas that's obscuring the light from behind it. So that's the Milky Way galaxy's disk. The Milky Way galaxy is a flat disk, spiral galaxy. And so if we look in the plane of the disk, that's what we see. If we look away from the plane, then we're largely seeing things from outside of our galaxy, I think. For the most part. Obviously, those two babies are from outside the galaxy. We're going to get some terminology for helping us understand what we're looking at in the sky. And so first, just some relative terms. Zenith. Zenith, to me, that's the name of a TV, right? A company. Don't think they're in business anymore, but when I was a child, they were a television. Zenith means the sky is directly overhead. Your zenith is whatever's directly overhead. So, my parents are in California. Their zenith is a completely different location than my zenith. There is something that's opposite to the zenith, directly underfoot, and that's the term for that is the nadir. I've got to figure out how to make the pin work here. I'm going to try my finger.
Zenith is what's above?
Yeah, so zenith is above. Come on. It's worked before.
You're not holding your thumb right.
Not holding my thumb right? No, that wasn't it.
I mean, you found the definition.
Okay. I don't know why this would not work now. Red pin. Oh, hey, look. Now all my writing is coming at once. Okay, so zenith is directly overhead. Directly underfoot is the nadir. Now, of course, you can't see the sky that's at your nadir because the earth is blocking it from your view.
How did you define nadir again?
What's directly underfoot. So zenith and nadir are opposite directions. And then you have the horizon. the horizon, okay, now if I draw it that way, it looks like the nadir is coming this direction, so I'm erasing it. But the horizon is out horizontal. Horizon, horizontal. See how tricky we are with these words? And so when you're out there observing things, those are some terms we use. Now here's another couple fun ones. We have the North Point. What do you suppose the North Point might be? Okay, where the compass points is correct. The North Point is the point on the horizon that's going toward the North Pole. South Point, not the mall. Point on the horizon is going toward the South Pole. And then there's also an East Point and a West Point. So those are pretty easy things. If we're going to locate something on the Earth, you know, like if I use my phone, I want to find something on the phone, what do we use for the coordinates for that? We use latitude and longitude. So latitude is the measurement north or south of the equator. And longitude is the direction east or west. Now, north or south from the equator. Let's start with the equator. What is the equator?
The center line that divides
Okay, the center line that divides the north half from the south half. The Earth spins on an axis. And so you have the North Pole coming out, the north spinning axis, South Pole the other axis. The equator is halfway between those. So we have that equator, and we measure the angles north or south of the equator for the latitude. So here in Lincoln, we're pretty much 40 degrees north latitude. We're 40 degrees north of the equator. And of course, if you were at the North Pole, what would your latitude be?
0 degree.
You what?
0 degree.
Not 0, because we're measuring from the equator.
365.
We measure from the equator. How far is it from the equator to the pole? 90 degrees. So the North Pole is at 90 degrees north. The South Pole is 90 degrees south. You brought something up that I have to talk about. He said 365. How many days are in a year? Okay, there's just a little more than 365. 365.2422 is the best approximation for the number of days in a year. It's not an integer number, first of all. So what that means is if we had 365 days in every year, then every roughly 4 years, we would have had one more day than 4 years because of the 0.2422. So that's why we have the leap year system. Now, the leap year system that we have is probably not what you think it is. Most people think that the leap year system is every year that's divisible by 4, we insert a leap day. How many people thought that to be the case? None of you?
Wait, what do you mean? So,
That every year that's divisible by 4, like 2000, 2004, 2000, that we insert a leap day, February 29th.
I didn't know what a leap day was
That's
in
it.
general. So it's like, I mean, I heard
It's
it.
an additional day that we put into the year.
I mean, I thought like that too.
That's what most people think it is. And that is what the Julian calendar was. The Julian calendar, I think it's Julius Caesar, introduced this calendar that added an extra leap day every 4 years. Because 0.24 is really close to 0.25, and 0.25 is 1/4. But it's 365.2422. So if you insert an extra day every 4 years, every 100 years or so, you've added one too many days. So you've got to take one out. And so the Gregorian system, which is the calendar we're on, is more advanced. The Gregorian calendar says you're going to add a leap day every year that's divisible by 4, except if it's a year divisible by 100, we're going to skip that leap day because we're adding in one too many leap days every 100 years. Except you're just a little bit short again, and so every year that's divisible by 400, you don't skip the leap day. And so for people like me, I lived through 2000. 2000 is divisible by 100. So we should have skipped the leap day. But the next rule came in because it's also divisible by 400. And so the leap day came back. And so for everybody that's alive right now, they didn't experience the difference between the Julian and Gregorian calendar. But you youngins, if you live to 2100, 2100 will not have a leap day. And then everyone will realize, yes, we're on the Gregorian calendar, not the Julian calendar. Don't you feel smart now?
Yeah.
You have any idea what I'm talking about?
Yeah.
Okay, I'm glad somebody does have an idea, because I know it's easy to get lost in all this stuff. Okay, so we measure on the Earth latitude north and south of the equator. And then longitude. Where do we measure longitudes from? From the prime meridian. The prime meridian, just a kind of randomly selected meridian. Meridian's another word, right? Another vocabulary word. The meridian is the line that goes from the north point through your zenith to the south point.
Can you say that again, please?
The meridian goes from the north point through your meridian to the south, or through your meridian, through your zenith to the south point. So if I were to actually identify the north direction, which is actually that direction, then my meridian is going like this. Right, it's going from the north point, straight above my head, to the south point. The prime meridian is the meridian that goes through Greenwich, England, wherever that is.
Wait, so what's
Is
a
that the
meridian in
GMT
general? Like,
time?
I'm not
What
getting.
else you said?
What's a meridian in general?
Okay, meridian, that's what I said. It's the line that goes from the north point up through your zenith to the south point.
Of the Earth? The line?
It's a line drawn in the sky above you. Yeah, from the north to the south. Well, not the north-south pole because
So
we
there's
can see
a
the south pole.
line. So there's a
Right.
meridian. That's what it's called.
The meridian is.
Sorry,
is-
I never.
Yeah, and that's why I'm defining the word because you're not expected to know. So we measure the latitudes as the angles from the prime meridian. Now in the sky, things are a little bit different. We don't have the same things, but we have what we call the celestial equator. We take the model of the celestial sphere, we just take the Earth's equator and go push it out there so the celestial equator is just above the Earth's equator everywhere. And we'll measure the angles north or south of the celestial equator. And we'll call that the declination. So declination is equivalent to latitude, but it's for the sky instead of the Earth. So latitude on Earth leads to declination in the sky. So that means that my zenith, since I am at 40 degrees north of the equator latitude, my zenith is at 40 degrees north declination. Question?
Is the reason why the prime meridian goes through Britain, England, because England was the biggest naval power at the time that it was created?
I don't know if it's naval power, if it's world power. It was, I believe, important at the time.
It's a really big shipyard area.
Is it? Yeah, I don't know. So the latitude leads to declination. Same idea. And so that's pretty easy. But then what about the longitude? We measure the longitude from the prime meridian. Well, we need something like that in the sky to measure from. And so the thing that's like the prime meridian in the sky is called the equinoctial colure. And the equinoctial colure is actually not shown here. I thought I had it here. I can draw it in here. The equinoctial colure is the line in the sky that goes from the north celestial pole to the vernal equinox to the south celestial pole. Well, that leads to just another vocabulary word. A lot of vocabulary words here. We have, well, here you can see zenith, nadir, celestial equator, horizon, celestial pole. The celestial pole is just take the Earth's poles and shoot them out to the celestial sphere. So the vernal equinox, as well as the autumnal and spring. Spring is vernal, so the other autumnal must be the other one. Is one of the two locations where the celestial equator, you see this? Wow, come on. Okay, now that I have it, so my pen is working, I can't zoom in now. Okay, let's not worry about zooming, although I want to later. The ecliptic is another new word. Lots and lots of words. Ecliptic I put this in quotes because it's patently incorrect. The path the sun takes around the earth. Why is that patently incorrect? The earth's going around the sun, not the sun around the earth. But as we view the sun in the sky, the sun appears to mark out this path in the sky. It's really the path the earth is taking around the sun. So to make this truthful, I just have to replace those words. And then it's true. But still, we think of the ecliptic as the path of the sun. It's an incorrect, it's basically a model. So the path the sun takes is not the same as the equator. The equator is based on the Earth's rotation. The ecliptic is based on the Earth's orbit around the sun. And it turns out that the Earth is tilted about 23.5 degrees compared to its orbit around the sun, which is what leads to our seasons. That's why the pictures like this always show a tilt. Notice the axis here for the North Pole is going this direction, and the equator is upward, but the ecliptic, this blue path, is shown horizontally. So what this illustrates is the Earth in this picture is orbiting in a flat plane, but it's tilted compared to that. So the vernal equinox is the place in the sky where the ecliptic and the equator cross. And of course, there are two of those, the vernal and the autumnal, on the other side. And so the equivalent to the prime meridian, where we measure the angles from, they're equivalent to longitude, are from that equinoctial colure. I'll just put EC for the equinoctial colure. And longitude on Earth is measured in right ascension, measured from that equinoctial colure. That's why for the lab final, you'll have to point out the equinoctial colure, because it's actually kind of important. It's a landmark for where we measure positions. Now, one last thing on this. We measure angles for longitude from the prime meridian. The Earth is rotating. How long does it take us to do one complete rotation?
Wait. Around the sun?
Man, this guy knows way more astronomy than I expect. Most people say 24 hours, right? The mean solar day, the time on average throughout the year from noon to noon, is 24 hours. But we actually do a little more than one rotation to go from noon to noon because we're going around the sun. And so in the time that we have done one complete rotation, we move forward a little, we have to do a little more rotation to get back to facing the sun. So it's actually a few minutes short of 24 hours. For argument's sake, I'm going to say 24 hours here, even though it's not the right amount. We look at the positions equivalent to longitude, and we simply measure them in hours and minutes and seconds. So we measure this right ascension in hours, minutes, and seconds from the equinoctial calure. So if the equinoctial calure is right above you, if it's at your zenith, in an hour, you will have 1 hour right ascension at your zenith. And in 2 hours, it's going to be 2 hours right ascension. It's really convenient because you can use a clock to gauge the right ascensions. And so the right ascensions go to just under 24 hours because that's how many hours there actually are in one rotation. Yes, Julia?
Can you explain really quick what declination is again?
Okay, so declination is exactly the same idea as the latitude. It's measuring north and south from the equator, but it's on the celestial, that is on the sky rather than on the earth.
Oh.
So the declination is exactly the same as the latitude, except for latitude's on the earth, declination's in the sky.
Wait, so, I'm sorry, that was what was throwing me off too. It's like, I didn't quite hear what, like, you meant by longitude. So it's like north to south,
Well,
but on Earth.
longitude is east-west, and that goes with right ascension. So east-west, okay, I want to change the color of my pen. Come on, baby. It's never going to let me do what I want. Okay, so east-west is longitude. East-west is longitude, and right ascension is measuring east-west in the sky.
Oh, so that's just a measurement, right? Ascension.
It's a measure. It's for position. So your GPS coordinates on Earth are latitude and longitude. The equivalent to GPS coordinates for the celestial sphere is the declination and right ascension.
So wait, you said that, the declination, it's like pretty much, it's still kind of like the same thing, but like on the sky? Is that what you said?
Declination is exactly the same as latitude, but in the sky. So if you know your latitude, you know the declination of your zenith, because they're the same thing. Okay, going to fun things, diurnal motion. You guys seen pictures like this? Do you love them? I think they're really pretty. What do those illustrate? If you're a flat earther, I don't know, something random. If you believe that the earth is a rotating sphere, then it makes really great sense because it's kind of like a spirograph or something. You have the earth has the North Pole and everything's going around that. And so stars, now everything's going around that. What's really happening is the earth is rotating, right? But once again, we're using the model of the celestial sphere saying the earth is here and the sphere is rotating around us. And so if you have a star that's on the celestial sphere and it's rotating around, it's going to describe a circle. The center of those circles is going to be, if you're in the northern hemisphere, the North Pole. If you're in the southern hemisphere, it'll be the South Pole. And so you can identify the North Pole really quite accurately from these pictures just by finding the center of all those circles. Now, how do they make these? You have to have a long exposure, long enough for the Earth to rotate a significant amount so you can see them. So they're very cool. This is showing the Earth's tip. Maybe I put it out of place. You see the ecliptic path, the celestial equator, things we've been talking about. Where the sun is in March, what did I call that? Or actually, I don't do that. also known as the vernal equinox. The vernal equinox is both the location in the sky and a specific time when they cross. And the vernal equinox is when we start spring. The autumnal equinox is, oddly enough, when we start autumn. And then we have the winter and summer solstices. Here's our winter solstice, and here's our summer solstice. Those are when the equator and the ecliptic are farthest apart, or as viewed from Earth, when the sun is the farthest south on the horizon, then that's going to be the winter solstice. When it's the farthest north on the horizon, the summer solstice. Question?
Sorry, I was a little confused about the celestial equator. So I'm just totally new to astronomy, so I'm literally just like, celestial equator? Like what is it again?
You just take the Earth's equator and expand it out to the, quote, celestial sphere, that model that I talked about last class period of Aristotelian thought. We know it's not correct. We know the stars are not on a crystal sphere rotating around the Earth. But it's an easy way to think about their locations. And so it's just taking the Earth's equator and expanding it out to the celestial sphere.
Okay.
Okay, signs of the zodiac. Here at Union College, I can get my internet blocked by trying to do a search for, signs of the zodiac. Because it's evil and wrong. Now let's make a clear differentiation between astronomy and astrology. I talked about astrology last class period, didn't I? It's a pseudoscience. Pseudoscience because they take something that is very meaningful or very scientific. They take the position the sun was in the sky, the day, the moment, the instant you were born. And they say, based on that, the position of the sun in the sky now is going to affect your life. There is no connection between where the sun is in the sky and your life that we know about. They're not drawing a scientific conclusion. They're taking scientific data and drawing a non-scientific conclusion. So that's pseudoscience. And of course, as Seventh-day Adventists, we consider this a form of sorcery. Although I'll tell you, most of these astrologers, I'm pretty sure, are just charlatans. People out there stealing money, basically. But the signs of the zodiac is not in and of itself something evil. The zodiac means the zoo. The signs of the zodiac is the zoo of constellations that reside plus or minus, I think it's 18 degrees from the ecliptic. The path that, as viewed from the Earth, the sun goes through in the sky. And so, different times of year, as viewed from the Earth, we see the sun in different constellations. So, for instance, on the day I was born, the Earth was over here. And so where do we see the sun? It was in the middle of Libra. So what sign of the zodiac am I? Not so fast, genius. That would be the case if there was any kind of semblance of truth in astrology. Depends on what part of the world you were in, some of the 16 to 1700 range. The Earth, the countries changed over from the Julian calendar to the Gregorian calendar. And depending on what country you're in and when they shifted, it was either 10 or 11 days that shifted. So people went to bed one night, it's Sunday night, like the 7th. They get up the next morning, it's Monday morning, the days of the week stay right. But you went to bed, I said, 7th. You get up and it's the 18th. They just shifted the calendar because the Julian system had gotten so far off. But they didn't change the signs of the zodiac. And so I'm a Scorpius, even though the sun is squarely in the middle of Libra, because, the Earth moves that far in 11 days. So to me, that's just a sign of, this really is kind of bogus. People who are true believers say, oh, no. They still it's correct. They just have to adjust everything because they know everything's shifting. Okay, sure. But those constellations are just the ones on the ecliptic. Now, what's the ecliptic? The path that the Earth takes going around the sun, but we tend to think of it with the celestial sphere model as the path the sun goes through. So it's the constellations we see the sun in. I can always advance that way. So constellations in general. Here's some pretty constellations. Scorpius. Scorpius has a bright red giant there. Antares, you've got the front of the scorpion, you know, or the tail of the scorpion, stay clear of that. Sagittarius, that's an archer. Can't you see the archer there? Totally looks, yeah. Obviously, everyone sees a teapot here. Looks a lot more like a teapot than an archer. The center of the Milky Way galaxy is right about here. We can see Sagittarius now. So tonight when we go out there, assuming we can see the sky when we go out there, I'm going to point out Sagittarius and point out where the center of the Milky Way galaxy is here. That's something I want you to know about. Now, that's not something you'll be able to see when we do the star quiz. You're not going to be quizzed over it because you won't be able to see it at that time of year. But I want you to know where the center of the Milky Way galaxy is so you could point it out to somebody and say, yeah, look at what I know. That's the center of the Milky Way galaxy. Here's a really interesting one. Ophiuchus, physician who mastered the strength of the serpent's venom. Serpens caput and serpens cauda. This is the one constellation that's split into two pieces because Ophiuchus is crushing the serpent, and you have the serpent on one side of Ophiuchus and the serpent on the other side of Ophiuchus, and Ophiuchus is split. Kind of cool, right?
Yeah.
A little mythology. There's stories to go with about half of the constellations. Now, these constellations that we use, they're the ones that most of the world uses today, but certainly not the only ones. These constellations come through handing down from the scholars of old to newer and newer. And so the scholars of old have changed from one country to another. So at one time it was the Greeks. At another time it was the Arabs. And so when we talk about astronomy, we'll find a lot of like star names are in Arabic. You know, something like Betelgeuse, that's an Arabic name. All the stars that start with Al, those are all Arabic names. Constellations are in Latin, and the names kind of tell us the history. But these constellations are from the knowledge base that led to Western culture. There's lots of other cultures. You have the Americas. The cultures of the Americas are not represented in these constellations. They have their own names for the constellations with their own mythologies. Likewise, you have, the Japanese or the Chinese. They have their own mythologies to go with these. Because everybody, I don't care where you live, you look at the sky at night and you start saying, hey, that looks like Uncle Bob, or whatever. And so everybody has their mythologies. So the mythologies I'll tell you about are going to be, like Greek mythologies and stuff. Well, Greek or Roman. But just know that these are not the only constellation definitions. Now these constellations, there are a total of 88 constellations. And I believe it's 48 of those 88 are ancient constellations that are pictures with some story behind it. And the other about 40 are let's fill up the rest of the sky constellations. And for those we have names like Triangulum. Look, there's 3 bright stars. 3 always marks a triangle. Triangulum. Microscopium. There's some pretty useless ones, But that's because of what a constellation means today. So if you look at these pictures, there are certain ones that you are probably going to learn pretty well. Like, you'll learn Lyra, the lyre. Maybe Lyra, I don't know. You'll learn Cygnus. And you'll hopefully learn Delphinus, because I love Delphinus. It's hard to see, very faint. You might learn Hercules. You might learn a few of these other ones. you look at these pictures, and those are kind of the old constellation. They're not what the current constellation is. So up there, you notice we have that magenta triangle. That magenta triangle is called the summer triangle. Summer triangle. It's a triangle made from 3 very bright stars, Deneb, Vega, and Altair. And Altair. So that's something I'll probably point out to you tonight. It's very easy to see. And we call that an asterism. An asterism is a star picture that is not the picture that goes along with the constellation. So asterisms may cover more than one constellation, such as the summer triangle, or they may be within one triangle or one constellation. The constellations themselves are areas in the sky. So this picture, we see this picture here of Lyra. That picture does not define Lyra. Lyra is actually an area in the sky. And so in today's world, each constellation has a fixed area. And if you take the areas of all 88 constellations, you have the entire sky covered. Every star belongs to one and only one constellation. Actually led to some consternation because you had some stars that were parts of more than one constellation. And so they had to say, well, which one's it going to be? Alpheratz, is it in Pegasus or is it in Andromeda? And so they had to just kind of make a decision. So when we go out tonight to look at the sky, the first thing that we always need to do is to kind of get our bearings, to find something that we can identify. And for me, that's always going to be the Big Dipper. Why the Big Dipper? The Big Dipper is something that we call circumpolar. Circum, around. Polar, the pole. It goes around the pole, but there's another piece to this circumpolar. It goes around the pole without being hidden. Any time of year at our location, we can see the Big Dipper. And so I'm going to find the Big Dipper because I know no matter what time of year it is, up here I can see it. Now, if you were to go down to, let's say, Bolivia, or where'd you say? Australia, it would fail utterly and miserably. But here it works great. So the Big Dipper is that collection of stars. The Big Dipper is not a constellation. It's an asterism. It's an asterism it's completely within one constellation. It's within Ursa Major. Question?
See, can you define in I understand constellation, it's just is that kind of like a group of stars that make patterns and stuff like that? Or?
Okay, let's look at this picture. This picture here, you have this piece of the sky. Do you see anything in that piece of the sky? This picture right here. Do you see anything there? Okay, if you take the bright stars, you can kind of draw a picture, which you can see in that other thing there. Kind of maybe looks like part of a clothes hanger so far, but then you can come back here. Now it's taking on some kind of funny look. Okay, that last line probably hurt. The picture. But this here supposed to look like a lion. And so Leo is this constellation. But if you look at this picture, and we know that nothing's going to work. Yeah, no, it didn't work. I've got to learn how to use this better. The constellation here is Oops, that was a bad line. Goes down again. Oops, actually went down again in the middle. Okay, I'm not doing a very good job. You can see I'm trying to copy the line. The line's over here. So something like that is the area for the constellation. So everything inside that funny box is the constellation Leo. So it's not just the connected dot picture.
How did you know that it was that?
I was copying this picture.
Oh, okay, makes sense. Wait, so then if we were supposed to define a constellation, would we just say like how would you define a constellation?
A constellation is an area in the sky.
Oh,
So if you're supposed to, so in the picture on the right,
Yeah.
so if you put pieces of all the constellation, that would make like the entire star, like the entire sky. Is that what
All of the constellations fit together like a jigsaw puzzle to fill the entire sky. Yes.
so that's like puzzle.
So now what about the lower one? You see anything there?
Is that like
Okay, you have the cross. The cross is an asterism. So the cross, right there, that's an asterism. Now if I can get this thing to come up, and if I can change the pin, come on. Change the pin to green. That's the cross. But this is also part of the constellation, Cygnus the Swan. Now if we want to draw the swan, there are more stars out here to make the wings come out further. This here is
wait, so is asterism,
asterism. The cross is an asterism.
so
It's
like a part of a constellation?
In this case, it's a part of a constellation, but with that summer triangle, it was parts of multiple constellations. So it's something that's not the official picture for the constellation.
And does that have to do with the pattern of it, or?
Was that like a famous part?
The famous pattern is generally the constellation one, so that's not considered an asterism. Okay, so this here is the butt of the swan. Here's its head. And if you look at the picture, you see that its shape is pretty much like this. So that Cygnus the Swan is that area in the sky. And the cross is an asterism. So you can see right away, you have to name 15 constellations and or asterisms. If you can find this, you have, first of all, the summer triangle. This is part of the summer triangle. And then you have that there, we'll just call it cross. Call it anything except for Southern Cross. Southern Cross, wrong. Southern Cross is something different. Call it Northern Cross, call it Cross, I don't care. Don't call it Crux either. That's different. And then you have the area is Cygnus. So if you can find out, you've got 3, right? That's 20% right there.
So the area, you mean like the constellation?
Right, the constellation is the area here.
Okay.
Yeah.
It's starting to, yeah.
So here's another one. Now, what do we have on the left pictures? We just went over them. What do we see in the upper picture? Okay. And so there is a pictogram of Leo the lion. Looks just the same, right? Yeah, absolutely. The lower one, Cygnus the Swan, looks just the same. One of the funnier things, I was talking about the apps you can get on your phone. I purchased one, and they put a picture of the swan like this. With the head up here. The thing is, the name of this star means butt. So I guess, according to that picture, it was just a butt head.
Oh my God.
So here is a picture of the sky. Right ascension. What's right ascension equivalent to on Earth? It's equivalent to longitude. Where do we measure it from? Prime meridian for longitude. For right ascension, it's measured from the equinoctial colure. So we have one axis here of our map has right ascension. The other axis is declination. So we have 40 degrees north. We're basically 40 degrees north, so everything here is going to, some time of the day, pass overhead. And you can see here, once again, this is showing constellations. So you have the constellation Andromeda next to Perseus, and we'll spend some time learning about these constellations, but I'm not going to spend time on that right now. Just one last constellation. You can see Orion here. Now, this picture shows Orion in the sky with his back to us. Most pictures I've seen have him facing us. They have him standing like this instead of like this. Artist depiction, right? Important things. This here is Orion's belt. So that is an asterism. This here is Orion's dagger or sword. And then you have this here, Betelgeuse, is his armpit on one side. This one here that I can never remember. It's like, I don't know, I'm not going to say. Front armpit, Rigel here, front foot. So you have the stars making up the picture, and the actual constellation is, well, do I have? Nope, I don't have a picture of it. Okay. The actual constellation is cut off really close here. It comes out something like this. Something, that's my best artist rendition. Artist rendering. Question, Myra.
Orion's a winter constellation, correct?
Yes, we will be able to see Orion by the time we do the star quiz. All right, so that brings us to the end of the old presentation. Stop my sharing